So now we can go to our full definition then of redox, and this is what you would see on BBC Bitesize. So oxidation is, it's not only the loss of electrons, which it is, it's also the gain of oxygen or the loss of hydrogen. Okay, so loss of electrons, gain of oxygen or loss of hydrogen, and reduction is the gain of electrons, loss of oxygen or gain of hydrogen. Okay, so that's our full definition of oxidation reduction. Foundations here tend to just use oxidation with oxygen and hydrogen, but on the higher tier you will be expected to do these electron transfers. Looking at this one, it's a little bit more difficult to explain via our foundation tier explanation, but if we look at electron transfer it's much easier. But we do need to just split this up so that we can see what we've got here. I'm going to separate, I'm going to have two halves to this equation. So I've got my magnesium element, my magnesium solid, and the copper sulfate is a solution. It's a solution of copper sulfate in water. So that contains copper 2+ ions, and it contains sulfate minus ions. Okay, and then on the other side of the equation I've made magnesium sulfate, and that's a solution, so it's magnesium sulfate in water, and that contains magnesium 2+ ions and sulfate 2- ions, and we've made this copper solid. So that's our atom. So we can see that on both sides of the equation we have got magnesium has become magnesium 2+, copper 2+ has become copper. The sulfate 2- hasn't changed at all, it's stayed the same. So as far as our reaction is concerned, the sulfate ions don't take any part in this at all, and they're called spectator ions. So what we can do with these, we can just ignore them in this equation, in trying to find our reduction oxidation equation, because they aren't oxidized, they're not reduced, they're not changed. So we're just going to ignore them out of the equation, and what we're left with is our magnesium metal. It's going to, we can see that it's going to change and become magnesium 2+ ions, and we can see our copper ions are going to change and they're going to become copper atoms. So now what I've done is I've shown how our magnesium is going to change and our copper is going to change, and I can write two half equations for these reactions, for these electron transfers. So see if we can see that on the next slide. So here we can see the ionic equation that I drew on the previous slide. So we've got our magnesium metal as a solid reacting with copper ions, which are in aqueous solution, and that's going to give us magnesium ions in aqueous solution and copper metal as a solid. So the half equations for these, so if I just take out the magnesium part, I can see that the magnesium becomes magnesium 2+ ions, and to do that it needs to lose 2 electrons. Magnesium's in group 2, so it has 2 electrons in its outside shell, it will lose 2 electrons. Copper, we know from previous equations that copper 2+ ions gain 2 electrons to give us copper metal. So there we have our two half equations. Magnesium is losing 2 electrons, so it is being oxidized, whereas the copper 2+ ion is gaining the 2 electrons and it is being reduced. Okay, so this we can explain in terms of electron gain and loss. So here's a typical question. How can you identify what's been oxidized or reduced in the following equation, in the following reaction? So what we have is calcium metal reacting with hydrochloric acid, and it's forming calcium chloride and hydrogen. So what actually is happening there? So we do need to be able to break this up into its ionic components and to see what are being changed, which I'll show you on the next slide. Okay, so follow me on this one. Make sure you've got your pen and paper, and we'll write this out. So what do? Here's our equation, hydrochloric acid. We can split hydrochloric acid into its hydrogen ions and its chloride ions. Calcium atoms or calcium elements is going to be calcium element. We can't split that into anything else. We can split the calcium chloride into its ions, calcium 2+ ions and chloride minus ions. And we can't split hydrogen gas into anything. It is just the element, and it's has H2. So if we rewrite this equation, so we've got all of the ions in there and all of the elements in there, we can write the charges in. So what we'll see is the hydrochloric acid becomes H+ and Cl-. The calcium chloride becomes Ca2+ and Cl-. Okay, so you can see there that we've split up the ionic compounds and we're left with the elements, the calcium and the hydrogen elements. So we have to ask ourselves what has changed from the reactants to the products. So if we have a look, we can see that the hydrogen ions have become hydrogen elements. So they have changed from the reactants to the products. What else has changed? Well, we can see that the calcium element has become calcium ions. So they have changed from the reactant to the product. What hasn't changed are the chloride ions. They have stayed as chloride ions on the reactant side and the product side. So they're spectator ions. So we don't have to worry about those. They haven't changed. They're spectator ions. But now we've identified the two parts of this that have changed, and now we can decide which change is oxidation and which change is reduction. Okay, so let's look at what's happening here. So our our hydrogen ions are becoming hydrogen gas, and so I can write that the two hydrogen ions have gained an electron each, so it's gained 2 electrons to give us hydrogen gas. Hydrogen H2 is the element hydrogen, and elements have no charge at all. So we've gone from a positive charge to no charge. If we look at the calcium, we can see that the calcium element has become calcium 2+ ion. So the calcium has lost 2 electrons to become the calcium 2+ ion. And there you can see that the calcium spit out the 2 electrons and become the Ca2+. And that's oxidation. So loss of electrons is oxidation. And the calcium's gone from having no charge, it's neutral, it's an element, it doesn't have a charge, to becoming an ion with a 2+ charge. And you can see that the calcium will lose 2 electrons and the hydrogen ions will gain 2 electrons. So we've got oxidation and reduction taking place at the same time. This will always happen in a chemical reaction. And you can see that the chloride ions are still there. They're still there at the beginning of at the start of the reaction. They're in the reactants. They're also in there in the products. They're not taking part in this reaction whatsoever. They're not changing. They are our spectator ions. So how are we going to write this? So you would be presented with this equation where it would ask what's being oxidized, what's being reduced. You would split it into its ions, and as you can see, we've got the hydrogen ions and the chloride ions, the calcium, then we've got the calcium ions, the chloride ions and the hydrogen. We can Cross out those chloride ions, they're spectator ions, they're not taking part in this reaction at all, and we can identify the element that is changing. So in this case it's the hydrogen, and the hydrogen ions are changing, and the calcium ions are changing. So we split that into two half equations, two half reactions, and the reduction reaction is where the hydrogen ions are gaining electrons to become hydrogen, and the oxidation reaction is where the calcium is losing electrons to become the calcium ion. And this is what I would expect to see at a higher level of question. So let's do an example, a redox example. So here we've got sulfuric acid reacting with zinc to give us zinc sulfate and hydrogen. So what do? We split it into its ions. So sulfuric acid is 2H plus and SO42-, that's its ions. We've got zinc metal or zinc element, and that reacts to give us zinc sulfate. So zinc sulfate is Zn2 plus, and then the sulfate ion SO42-, and we've got hydrogen gas H2. So what happens? We can see that the hydrogen ions take part in the reaction because they're changed to hydrogen gas, the element hydrogen. We can write that reduction equation because the two hydrogen ions gain 2 electrons and they become hydrogen molecule. We can see that the zinc element becomes zinc ions, and that's an oxidation half equation because the zinc atom spits out 2 electrons to give us zinc 2+ ions. So we can explain in terms of gain and loss of electrons what has happened in this reaction. And as you can see, the sulfate ions haven't changed. They're the same on the left hand side as they are on the right hand side, and they're spectator ions, and they we don't have to write any equation for those whatsoever. Okay, so it's your turn now. Explain in terms of gain or loss of electrons that these are redox reactions, or this is a redox reaction. So what are you going to do? You're going to split it into its ions, and nitric acid is going to split into hydrogen ions and nitrate ions, and the magnesium nitrate is going to split into magnesium ions and nitrate ions. So here we've split it into its ions. Now you need to decide which is the redox half equation and which is the oxidation, which is the reduction half equation and which is the oxidation half equation, and write them out. So which species have changed and which species have stayed the same. There's a set of questions on the next slide for you to have a go at. So if you answer all the questions, you can do that on a piece of paper, or you can do that electronically using Word. And then on the slide following are the answers, so self-correct your work, self-assess and correct your work. If you can attach your work to this assignment and send it in to me, so turn it in and then I can review what you've done. But obviously do self-assess it and do make sure I can see where you've made corrections or where you've done the answer correctly and you've given yourself a tick. Okay, if you need any help then just send me an email. I am available.